Let's do some examples using the multiplication and division properties of square roots. So just to recap what these properties says, the multiplication property says that if you have two square roots that are multiplied together, you can instead think of it as the square root of a multiplication. So instead of a multiplication of two square roots, it's a square root of a multiplication. And the division property is very similar, but with division. So if I have the square root of x over the square root of y, that's the same thing as the square root of x over y. So let's try to use these and see what our homework is going to look like. So part A says we have 4 square root of 3 times 5 square root of 7. So one thing to pay attention to is that this property only works for numbers that are under square roots. So like the 3 and the 7 here, we can combine square root of 3 and square root of 7 and multiply them and get square root of 21. But that doesn't work for the coefficients out front. So really what I want to do here is use the commutative property. Commutative property of multiplication says that I'm allowed to switch the order of pieces that are multiplied. So instead of 4 times square root of 3, I can switch the square root of 3 and the 5, and I'm just moving around the order. And this sort of, for some people, really helps them see like, oh, I'm just taking the 4 times the 5 and getting 20, and then the square roots can multiply. But I can't simplify this coefficient out front multiplied by the square root. Square roots only multiply by other square roots by that property. So we're done. That's it. I should mention, though, that you should look to see if what's under the square root has a perfect square factor. Remember, that's how we simplify square roots, but this 21 doesn't. So let's try the next one. So I have 5 square root of 12 times square root of 6. So by the multiplication property, I can write this as the square root of 12 times 6, which is 5 times the square root of 72. 72 does have perfect square factors. So let's make a little list of our perfect squares just so they're readily available. So the factors we should be looking for are numbers like 4, which comes from 2 squared, 9, which is 3 squared, 16, which is 4 squared, or 25, which is 5 squared. Sometimes we might go up to 36. Actually, 36 does go into 72. But if you didn't see that, you could maybe try 9 or try 4. There's actually 4, 9, and 36 all go into 72. But if you see that 36 is a factor, it's 36 times 2, that'll just make our steps a little shorter or make it go quicker. So then how I'm viewing this is the square root of 36 times the square root of 2. So this is actually the multiplication property in reverse. We're starting with a product and we're viewing it as 2 separate square roots. And the reason we're doing that is because the square root of 36 simplifies. So that's just 5 times 6 square root of 2, which makes our final answer 30 square root of 2. All right, so that you could have gotten to that same answer with a variety of different steps here, right? So another option might be if you saw that 4 goes into 12, you could have simplified the square root of 12 and used that perfect square right away. So there are different ways your work could have looked, but regardless, you should get that same answer. Let's try another one. So we have 2 square root of 10 times square root of 2. So using the multiplication property of square roots, we're going to write that as 2 square root of 20 because the square roots can multiply with each other. Now we check to see if any of these perfect squares go into 20, and 4 does. So we're going to write this as 2 square root of 4 square root of 5 because 4 times 5 makes 20, and 4 is a perfect square. That's really what we're focused on, is that square root of a perfect square will simplify. So square root of 4 is 2, and then 2 times 2 makes our final answer 4 square root of 5. All right, hopefully that's making sense. Part D here is very similar to part A, where we have two different coefficients. So remember what we did in part A was sort of recognize that if these are all multiplied, we can flip the order around. So I can just multiply the 10 times 3, and that gives us 30. Maybe I'll do it this way. And then I want to multiply the square roots together. That would be the square root of 48. 6 times 8 is 48. So the coefficient out front, we don't care if that's a perfect square or not. It's already simplified. It's the square root I need to simplify. So I go through and try to find perfect squares that go into 48. 4 definitely will do it. So we need to figure out 4 times what makes 48. And it's 4 times 12. So take square root of 4, square root of 12. The 30 is still there. The square root of 4 is 2. So this gives me 30 times 2. But then the square root of 12, I feel like there's another perfect square that goes into that. 4 also goes into 12. So it turns out that we could have actually used 16. 16 goes into 48. And if you see a larger perfect square that goes into a number, that's always going to make your work more simplified and go quicker. But if I didn't see it, not a big deal. I still get there. Let's try it. So 30 times 2 is 60. And then times 2 times square root of 3. So the 2 comes from this square root of 4. Square root of 3 doesn't simplify, so we just leave it. So final answer is 120 square root of 3. All right. Got a couple more. These have fractions, and I know how most of us love fractions, but again, we gotta first just go like, it doesn't have to be hard just because it's a fraction. And actually this first one's pretty easy. Because even though it's fractions, it's still just a multiplication problem. The multiplication property says I can just multiply these together. 5 times 1 over 6 times 6. Right? Square roots over square roots. And then, now we're using the division property, which says if we have the square root of fraction, we can view it as the square root of the top and the square root of the bottom separately. Which is good because then it just simplifies since the square root of 36 is just 6. So the most simplified answer is square root of 5 over 6. Let's see if hopefully part E or part F works as nicely as part E did. So I'm going to do the same step first, is just multiply the fractions. 2 times 3 is 6. 5 times 20 is 100. And we can do that multiplication because they're both under a square root, right? As long as both pieces are under a square root, we can combine them or multiply them. So now we use that property of division. So square root of 6 over square root of 100. And square root of 100, even though I didn't put it on my perfect squares list, square root of 100 is just 10. And so that's final answer. The only thing we would want to check to see if there's a perfect square that goes into 6, but 4 doesn't go into it, so no, it's not going to simplify. So just to make sure we got this, let's do this group work together and make sure it's working out. So how to simplify a square root is to look for perfect square factors. That's what simplify means. It's perfect square factors. So let's start with 18. Is there any perfect square that goes into 18? The answer is, well, yeah, 9 does. 9 times 2 makes 18. And the square root of 9 is 3. So 18 simplifies to 3 square root of 2. Sorry, it's getting weirdly focused there. That's all we mean by simplify, is make sure that any perfect squares, we actually take their square root. Let's try part B. We're going to use the multiplication property. 2 times 6 is 12, so this is just square root of 12. But I can't stop there. We got to look for perfect square factors. 4 is a perfect square that goes into 12. So we need to actually take the square root of 4. The square root of 4 is 2, so our answer is 2 square root of 3. So these aren't so bad once we get a hang of it and once we really memorize our perfect squares and know what to look for. All right, let's do one with these coefficients out front, because remember, square roots multiply by square roots. Numbers out front are coefficients multiply with other coefficients, but we can't combine non-square roots with square roots. So what I'm going to do, I'm just going to rearrange it, because I'm going to do the 2 times the 3 and get 6, and then the square root of 5 times square root of 8 and get square root of 40. We're not done until we check for perfect square factors. 4 goes into 40. So we need to write 40 as square root of 4 times square root of 10 because the square root of 4 simplifies. So 6 times 2 times square root of 10. And so last step is to do that 6 times 2. Because once they're both non-square roots, then we can multiply them together. Good, I hope that's making sense. Last one, just because it's a fraction doesn't mean it's harder. We're just going to multiply the fraction. So we multiply across the top and get 35, and across the bottom and get 16. And then use the division property to write these as 2 separate square roots. And this is great because the square root of 16 is just 4. I just need to make sure I'm writing 35. And then for square root of 35, we should look to see if there's a perfect square that goes into it. 4 doesn't go into 35, 9 doesn't go in there, 16 doesn't go in there. So I think we're good. So once we've checked that perfect squares don't go into 35, then we're done.